What if the thing that looks most like dark matter is not a new invisible particle, but a swarm of particles that barely live for a second? In the energy filament theory, the energy sea is constantly boiling up tiny filament knots, short-lived structures that appear, decay, and dissolve almost instantly. They are individually fleeting, but collectively everywhere, and their life has two faces that can mimic both extra gravity and a cosmic noise floor. Phase 1 is while they are alive. Even if a knot exists for a blink, it still has an effective mass in this language, meaning it slightly tightens the surrounding sea and leaves a tiny tension dent, like a small dimple pressed into a trampoline. One dimple is nothing, but if a region is continuously producing and destroying huge numbers of these short-lived knots, then you ident it, stack statistically into a smooth, persistent average gravity base. From the outside, that base could hold up galaxy rotations in the outskirts and deepen gravitational lensing, so it looks like an extra halo of unseen mass. The scale doesn't have to be exotic. Averaged over absurdly large volumes, even a few grams per trillion cubic kilometers can add up to a meaningful gravitational carpet. The key is not long individual lifetime, it's constant replenishment. Phase 2 is when they die. When a short-lived knot collapses, it dumps its structure back into the sea as weak, broadband, low-coherence disturbances, like a hiss rather than a clean tone. Each hiss doesn't travel far or stay organized, but there are so many that they can build a pervasive background. In the early universe, when the sea was in a violently mixed boiling phase, that noise would get rapidly blackened. Repeated scattering and mixing ground details away and driving the spectrum towards a universal smooth shape, creating a near-perfect black-body floor that can serve as the base of the cosmic microwave background. In later, thinner conditions, those same dissolving disturbances are less likely to be fully reprocessed, so they can linger as a diffuse radio background after you subtract discrete known sources. This is why this idea is sharper than a slogan. It doesn't just say maybe something else exists. It says the same population can produce two linked effects, a smooth average gravity layer from the living dents, and a smooth isotropic noise layer from the dying hiss. You can picture it like a city with endless tiny delivery scooters. Each scooter is gone in seconds, but because new ones keep spawning, the flow is steady. The city feels like it has a permanent extra traffic field. Or imagine raindrops on a pond. Each drop is brief, but constant rain creates a stable background chop, even if no single drop matters. The razor argument also changes. Dark matter in the mainstream story often means a new ingredient that must exist, but has not been directly nailed down in a single decisive detection. Short-lived unstable particles, on the other hand, are not hypothetical in physics. Laboratories have confirmed hundreds of unstable species and short-lived resonances. In this picture, we are not forced to invent a brand new invisible world. We are being forced to count an already known kind of world into the cosmic budget, and to ask whether its collective average effect was misfiled as a permanent invisible halo. Most importantly, this comes with a falsifiable signature, not a vague escape hatch. When galaxy clusters merge or experience strong shocks, the production rate of these short-lived knots should spike, and the two-phase effect should show up with a specific four-part pattern. It should be event-like, rising mainly during big merger events. It should be delayed, with the deepening of the average gravity base lagging behind the shock front and cold fronts. It should be accompanied by non-thermal radiation boosts, like stronger radio halos or relics and more organized polarization. And it should be more turbulent at the boundaries, with stronger ripples, shear, and patchy fluctuations in brightness and pressure. If these four traits rise together, it becomes harder to wave everything away as just a cloud of invisible matter drifting silently. Next episode we connect this to the bigger map. If short-lived knots can create both gravity carpets and noise floors, what else in cosmology might be a time-averaged effect of an evolving sea rather than a permanent new substance? And how does that change what we look for in the sky? Tap follow, share it on New Physics, Clear Universe.